What if we told you that the planets, the asteroids, the galaxies, stars in general, everything that you can see just constitutes less than 5% of the total universe? So what exactly is the rest of the 95%? Well, that is a mystery, and that mystery is collectively called dark matter, and it remains totally invisible. Research suggests that about 70% of the universe is composed of dark energy, while the remaining 25% is composed of a mysterious substance known as dark matter. If that got your attention, stick till the end of the video to know a lot more. Hey aerospace enthusiasts, welcome back to our channel, Space Tech Zone. Even with all the technology that we have, dark matter is still one of the most mysterious substances in the universe that we still find hard to crack. Everything around us does emit or absorb light, and they're all made up of normal matter, which includes particles like protons, neutrons, and electrons. But the best part is that it only accounts for 1/6 of the total mass in the universe, and the remaining 5/6 is all dark matter. We can, to some extent, confirm the existence of dark matter by observing some of its effects on matter and light, particularly in large-scale astrophysical environments. So you might be wondering, if scientists cannot see dark matter, how do we know it even exists? Well, scientists calculate the mass of large objects in space by studying their motion. Unlike ordinary matter, dark matter also does not interact with electromagnetic force. This means that it does not absorb, reflect, or emit light, making it extremely hard to spot. Researchers have been able to study the existence of dark matter only from its gravitational effect on visible matter. So here are 10 things we know about the mysterious dark matter. 10. More than one particle. We know that ordinary matter is just made up of everyday particles like protons and electrons and other exotic particles like neutrinos, muons, and pions. This made researchers ask a question about dark matter. If dark matter makes up a huge percentage of the entire universe, it could be a lot more complicated than ordinary matter, right? Well, according to physicist Andrew Katz of Harvard University, there is no good reason to assume that all the dark matter in the universe is built out of one type of particle. There are high chances that dark protons could combine with dark electrons to form dark atoms, producing configurations as diverse and interesting as those found in the visible world. 9. Existence of dark forces. With the presence of additional particles of dark matter, there is a high possibility that dark matter also experiences forces that are analogous to those felt by regular matter. Some researchers have searched for dark photons, which would be like the photons exchanged between normal particles that would give rise to the electromagnetic force, except this one would be felt by dark matter particles. Physicists in Italy are gearing up to smash a beam of electrons and their antiparticles, known as positrons, into a diamond. If dark photons exist, the electron-positron pairs could destroy and produce one of these strange force-carrying particles that would be potentially opening up a brand new sector of the universe. 8. Properties of dark matter. You might be thinking how dark matter was even discovered. Well, dark matter was through its gravitational interaction with ordinary matter, which shows that there's something else other than ordinary matter. Astronomers were examining spiral galaxies way back in the 1970s, expecting to see the material in the center move much faster than on the outer edges. But instead, they were shocked because they found the stars in both locations traveled at the same velocity, indicating that the galaxies contain more mass than what could be seen. Some of the gas within elliptical galaxies also indicated a need for more mass than what was visible. Invisible objects and clusters of galaxies would fly apart if only the mass they contained were visible to conventional astronomical measurements. Understanding the true nature of dark matter is quite difficult, but there are some theories that suggest that dark matter particles should have their own antiparticles, meaning that the two dark particles would destroy when they meet. The Alpha Magnetic Spectrometer experiment in the International Space Station has been searching for telltale signs of this annihilation, and they were successful in detecting hundreds of thousands of events. Even then, scientists are still not sure if they're coming from dark matter, and the signal has yet to help them pin down exactly what the dark matter is all about. 7. Presence in every galaxy. We already mentioned that dark matter exists in the universe a lot more than regular matter, So it makes a lot of sense to think that dark matter would be the controlling force that organizes large structures such as galaxies and galactical clusters. Researchers very recently announced that they found a galaxy named NGC 1052 DF2 that seemed to contain hardly any dark matter at all. With this discovery, researchers came to the conclusion that dark matter is apparently not a requirement for forming galaxies. Later, there was news that there were missing measurements from the distance to the galaxy, meaning the visible matter was much dimmer and lighter than the first findings. And now the chances of more of its mass being in the dark matter is a lot higher, just like how it was suggested previously. So this means that dark matter is there in every galaxy. 6. Electrical charge. Scientists did study a signal from the beginning of time to suggest that dark matter might even have an electric charge. The radiation with a wavelength of 21 centimeters was emitted by stars when the universe was in its infancy, just about 180 million years after the Big Bang. It was then absorbed by cold hydrogen that was around at that time where this radiation was detected. In February of 2018, the signature suggested that hydrogen was a lot colder than what scientists initially thought. Astrophysicist Juan Munoz of Harvard University hypothesized that dark matter with an electrical charge could have drawn heat away from the all-pervasive hydrogen, sort of like ice cubes floating in lemonade. So right now, we don't have any concrete evidence for electrical charges in dark matter, but we do have theories suggesting that there will be electrical charges inside dark matter. 5. Not smoothly distributed. Dark matter not only forms filaments on supergalactic scales, but it is also not evenly distributed within galaxies. Dark matter does not interact sufficiently to produce anything as dense as planets, although it does have changing density halos that move about in galaxies. Dark matter density is often higher around galaxies' cores. Because dark matter does not spin with the disk of stars that we see, solar systems like ours are always surrounded by a wind of dark matter particles. 4. Dark matter is everywhere. Well, things like planets, stars, asteroids, or even galaxies and anything that we can observe only constitutes less than 5% of the total universe. Researchers suggest that about 70% of the universe is made up of dark energy, and the remaining 25% is made of a mysterious substance known as dark matter. We cannot see it nor understand it, but the only thing that we're sure about is that something like that does exist. Dark matter is also really hard to study because there's no way of seeing it. It's a weird thing that doesn't interact with light, making it totally invisible. The only way we know that dark matter exists is because of the way it affects the universe. 3. Responsible for the structures in the universe. Well, right now we know that dark matter does not interact much with itself or any other stuff. But again, it happens to be the very first type of matter to settle down when the universe expands, and the very first to form structures under its own gravitational pull. So you could say that dark matter is responsible for seeding the filaments along which the galaxies later form when visible matter falls into the gravitational potential created by dark matter. When you look at the formation of structure in the universe, you always look at the distribution of dark matter and not that of visible matter. 2. Different varieties of dark matter. Scientists did come up with several models for what a dark matter might look like. When it comes to what dark matter looks like, the current leading candidate would be WIMP, or a weakly interacting massive particle. There are other possibilities that include particles conveniently already predicted in the models of supersymmetry, a theory that adds a new fundamental principle to correspond with each one we already know. There are so many groups of scientists that are also searching for dark matter particles called axions. But again, there is no reason why there should be only a single type of dark matter particle, especially considering the fact that a massive part of the universe is all dark matter. 1. Dark matter a myth? There are high chances that dark matter might be an undiscovered particle, or it might be almost nothing at all. Some scientists believe that the effects that we associate with dark matter are actually caused by gravity. There are high chances that our existing theory of gravity is flawed. The effects of gravity that we attribute to the dark matter could simply be a different version of gravity that we still don't understand. Despite decades of research, nobody has directly detected a dark matter particle, and the only evidence that we have right now is indirectly inferred from the gravitational pull. Physicists have always been on the lookout for rare interactions of this particular dark matter in many Earth-based experiments, starting as early as the 1980s. They're also on the lookout for astrophysical evidence for dark matter, such as signals from the mutual annihilation of dark matter particles. Right now, we could conclude that some type of dark matter does exist in the universe, a matter that is very different from any of the known particles in the standard model. We know that dark matter exists, but we don't know exactly what it's made up of. And that's a wrap for today's video. What do you think about dark matter? Is it just another hyped up theory of scientists? Do let us know in the comments section below. That's about it for today. Hope you enjoyed the video. We'll meet again in the next video.